So Andrus Padar will demonstrate us 3D topographic models as a counter-UAS planning tool. So first of all, please explain us what is UAS.
UAS is common abbreviation of unmanned aircraft system. Yeah, we mostly know the UAV.
Yeah.
This is only one device. But usually we have some kind of bigger systems that consist of from multiple elements. Okay, some technical issues. Okay, ladies and gentlemen, thank you for this great opportunity to share and learn. I'm not an analyst working every day with the ArcView or ArcGIS solutions, but I'm more close to the customer, and I try to be a smart customer that knows what's possible, what's not. And so sometimes I do also some hands-on. Okay, is it my slideshow up and running? No, not yet. This is my side, and here you are. Okay. This title of presentation is quite demanding, but as usual, I discovered that there is much more things that I thought that I know, but don't know yet. What's possible to learn? And I would like to thank you for all of the specialists that supported me yesterday evening and made me a little bit smarter on this. My intent is to cover following topics. Because you are quite seriously familiar professional on the ArcGIS, probably I will not need to touch such details, but I would like to explain the problem. What does it mean? Why we need to deal with the countering unmanned aircraft systems? Then some technical part, what does mean detectors, how we discover UAVs, and how to defend them against them. And then we will lead us to the planning issue. And if possible, if it will be successful, then I would like to do a short live demo too. Drones. We have many different types of drones. And depending on the size, on the takeoff weight, the threats are also different. There is one list. Of course, this list might be double times, triple times bigger. At home, we quite often have the tiny toy drones. It's quite harmless. But in modern war, we saw every day the news about seriously dangerous and killing machines that's now becoming more important even than human fighters. If we talk about the threats or problems that might be related, then those toy drones, they might annoy us. We don't like the sound, we don't like that something is moving next to our head. But if you talk about the rally drones, this is kind of a sport. It's interesting, they are much faster, and it will be dangerous if you collide with them. Those FPV rally drones, they might be used also as a combat kamikaze drones. And we need to analyze, to assess the risks, what kind of drones might be in our monitoring spectrum and what we need. It's not a good idea to just buy some equipment and start defending. This is like in cybersecurity. First, we need to know what kind of assets need protection, and then define the risk, and then choose the solutions. Unfortunately, all the solutions for defending against the drones have some kind of limitations, as usual. In general, this process looks like this. First, we need to detect and discover something, then make sure what it is exactly, is it dangerous or not, and only then we can make decision. Should it defend, kill, or repel it? It depends on the situation. For detection, we need sensor system, and those technical sensor systems, they had also their own range and limited ability to detect those small artificial birds on the sky. There is a number of different sensors that can be used for different defending or detecting the drones. As in cybersecurity, we know this security onion model. For an efficient security system, you must have multiple layers of the sensing, for example. Acoustic is the one edge, and some radio beacon receivers on the other end. Every of them has their own capabilities, a different content, but if you put all of those sensors together, well, unfortunately we don't have enough money usually. We need to choose 2 or 3 of them. And some sensors are passive, they are listening only. Some sensors are active. Passive sensors are not so demanding against the view shed or direct visual line of sight, because for receiving signal, you don't need so much space. I have a drawing about that. How about defending? We can separate 3 different dimensions of defending. Yes, first, go away. I will not touch you, but just force you to leave the area. We can call this repulsion. But it's not always a good idea. If the drone is carrying a bomb, then it's better to get it. If possible, take safely over the control. Or if carrying explosives, then it might be that safest option is to kill it. For soft effectors, like mild methods of repulsion, we mostly hear about the drone guns, jammers. It's electronic warfare. We separate in this as a list of effectors, satellite navigation jammers and satellite navigation spoofers. Technologically, they are different. Those cadets who are flying the drones, they at the Estonian eastern border, they know that this is a serious problem right now. We can't fly our drones because of the presence of Russian electronic warfare. Also, quite soft method is blinding the camera by laser, or like a prevention, that we define on the civil commercial drones the zones that are prohibited to fly. It also helps if pilot is cooperative. For taking over, we have 3 methods. One method is that we will tell to the drone that your home point is located here. And if it's coming to home, then it lands on the destination that we put on the map. Cyber takeover. This is quite interesting topic. I haven't seen it in practical life, but I have seen some live demonstrations. As usual, in the cybersecurity, new drones are not easy to take over, but older drones, there it works quite well. And it's like very sharp and almost no collateral damage, because I will attack precisely only this drone and force it to land or move to the position that I will define. And the last hijacking method is physical capture by the net, for example, or eagles, or different methods. Then destructive effectors that also need some support of geospatial planning. Of course, the firearms as the oldest. Killer drones might be the best option on the proximity of airfields, but not well known. We have seen them on the commercial exhibitions, but not in action yet. And the first 2, high energy laser and high power microwave, they are on the military battleground. They are present, but they are extremely expensive. Approximately 15 million euros per one station is the cost of laser weapon. But of course, it's decreasing. What is the problem? Well, we need to plan where to put our sensors, and those sensors must be efficient to discover the drone, incoming drone, as fast as possible. What is common regarding kamikaze drones? They are really fast, and as you see on this picture, this military base, after radar or some kind of other radio spectrum detector will discover them, you will have only 200 seconds. It's it's a little bit more than 3 minutes. But during those seconds, you need to discover what it is, analyze the threat, is it dangerous or not, and then defend if needed. That means that decision-making procedure must be, our OODA loop must be really fast. But new drones, they are much faster. Okay, mostly, if somebody is annoying or filming us, the Mavic 3, probably this is quite slow, but kamikaze drones, they're almost reaching 200 kilometers per hour with the bomb. And it means that we have even less time, 1.5 minutes to act. It means that we need to put the sensors on the ground on the most efficient place, that we will have more time for acting and decision making. And those limitations are every device, depending on the technology, radar or radio direction finder, they have limited range of activity, and also have the limited range the other devices that are used to kill the drone. If we need to defend us in the urban environment, then radio spectrum is full of noise, and it makes detection much more complicated. And always, if we are going to kill or capture the drone, we need to think about avoiding potential collateral damage. This drone will not fall onto buildings or people on ground. And how to choose then? This is the list of the ranges. I will not stop on that detail, we can read it later. But we need to provide kind of planning. First, where to put device location, then the height from the ground. Then higher you are, then bigger is the distance, but you can't see the low proximity area. And depending also about the potential attack scenarios, what is most probable path for incoming drones? This is like a complex of different dimensions we need to plan, and we have in the world quite a lot of experience on the military conflicts, mostly in desert area where is almost no obstacles, but quite a few good experience protecting urban environment. Yeah, okay, airfield, airports. There we have something. And that means that we are not highly professional at it. We are doing or learning by doing. And how to do? We need to take into consideration how the radio waves are propagating in the space. We need, if it place the radar, you understand how moves back the reflected radio signal, and choose a most efficient place for that. And also, what is specific to the radars, that they have like a conic area just above the heads, where they can't see. It means that we need to put them close to each other to cover the area. Also priorities, what we are defending, the cost of them, evaluate depends, or they will define for us the framework, how much we can invest for protection. And some planning. I'm mostly working with the other topics, like kind of doctrines or the different kind of operational tasks, but I differ or understand that regarding GIS systems, there is 3 options. Kind of fast food, there's ready-made products. Maybe already some analysts made me a good report. What's possible, I like it. It's like a dish of the day. It's good, delicious, but I will get it very fast, but I can't change the parameters. And if you need to do the proper analysis, then I need a la carte solution for GIS. And I recognize those as well. Dish of the day for me is all the applications. Also, you see this powered by Esri. Solutions or applications that I can access via website or on the mobile device. And it's quite easy to operate to get some very initial results. I don't see the watch, how many time I have. 1 minute, okay. Then it helps just browse, to go fly higher, fly lower, and see over the horizon and choose the place. And later go physically to the landscape and check them. But this is like a simple solution. But if we need to plan something, also it's important to see like the complex picture. For example, Tallinn prison also has the problem of incoming drones that are bringing or smuggling in some kind of equipment. Why? It means that in the protection, organize the protection of Tallinn airport, we can use also tail sensors, because our airstrip is on the proximity or detection range of this equipment. Exactly the same with the effectors. a la carte for us, of course, is ArcGIS solution. I discovered that it's much more complex than I understood. Even viewshed tools, we have 3 different versions of that. Some of them were not licensed for me. But we still managed to do here some kind of this analysis. And just play and test. I will create very quickly the viewshed on the new location and can see is it overlapping or not. Okay, probably I don't have time for demonstration anymore, but if some of you are interested and have some similar problem, then I'm happy to contact you and exchange the ideas. I really hope that I can learn from you.
Okay, thank you, Andrus. Again, I like the spirit and passion. We have one question on Slido. Any practical experience with anti-drone activity or only theory so far?
We are, of course, training. For example, territorial defense units. We are testing some kind of drone detection and drone defense systems, and also those operators need to be trained in practical situation. Luckily, our situation is not so bad as in UK, for example, and we have only a few those pilots who violating the rules. But civis pacem parabellum. We need to prepare for that.
Okay, thanks a lot. Thank you, guys.